Okay? What would happen if Ceres hit the Earth? What would happen if this thing hit the Earth right here? Would that be good? Oh, nobody wants to. Yeah, things are going to be bad. Things would be really bad. This thing is 30 times wider than the one that hit the Earth and caused 70% of everything to die. If this one hit us, I would not be surprised if 100% of all life died. We would actually have an even bigger problem. I actually am pretty sure that if something this large hit the Earth, it wouldn't just create a crater and throw dust up. It would actually liquefy at least part of the crust. So it would turn at least part of our planet into lava. Okay? So that's a big problem. So I'm pretty sure this would just wipe out everything. Like, when the one hit us and killed off almost everything on the planet, that wasn't the end of the world, because what was left was able to repopulate over time. This, I think, would leave nothing left to repopulate the Earth. So, do we need to worry about Ceres right here? Do we need to worry about Ceres? Do we need to worry about it? About this guy specifically hitting us? Actually, we don't. We don't have to worry about Ceres hitting us. And that's because of where Ceres is, okay? We do have to worry about asteroids hitting us, but we don't have to worry about this one specifically because of where it is. Do you guys know where 99.99% of all asteroids are? Do you guys know what part of the solar system they all are? There's a specific place in our solar system where all of the asteroids get together. Almost all of the asteroids get together. Yeah, so somebody posted it. It's called the asteroid belt, okay? It's called the asteroid belt, and we need to know where it is. So let me draw a quick little diagram right here. Okay, right in the middle, we got the sun. And then we got our terrestrial planets. That's Mercury, Venus, Earth, and Mars. And by the way, I'm not drawing this to scale, and I'm also not labeling the individual planets. But yeah, we got the Sun, Mercury, Venus, Earth, Mars. Okay. Before we get to the Jovian planets, that's where you're going to have your asteroid belt, okay? That's where you're going to have your asteroid belt. So right after the orbit of Mars, you're going to have the asteroid belt. Kind of do this a little faster. And by the way, I am not trying to draw really squiggly orbits here. I'm just trying to shade in a region here. So that is the asteroid belt. There we go. Asteroid belt. Oops. There we go. Okay. Now, like I said, I'm not saying that we have a bunch of crazy orbits here, like a bunch of swiggly orbits. All of the asteroids orbit the sun just like tiny little planets, okay? They all orbit the sun just like tiny little planets. And they all orbit... Any asteroid that's in the asteroid belt is orbiting in the same direction as the planets, okay? And then after that asteroid belt, you've got Jupiter, Saturn, Uranus, and Neptune. So basically, the easiest way to remember where the asteroid belt is it basically, in our solar system at least, cuts in half the order of the planets between the terrestrial planets inside the asteroid belt and the Jovian planets outside the asteroid belt. And 99.9999% of all asteroids are in this asteroid belt. There's millions and millions and millions and millions of them, orbiting like tiny little planets. Now, why don't we have to worry about anything that is in the asteroid belt? Well, here's a quick question, pretty easy question, yes or no. Does Earth's orbit cross through the asteroid belt? Does Earth's orbit cross through the asteroid belt? Yes or no? No, it doesn't, right? It doesn't. So as long as we stay on our orbit and they stay in their orbit, we're going to be totally fine, okay? We're going to be totally fine. But every once in a while, stuff does come out of the asteroid belt, okay? Every once in a while, stuff does come out of the asteroid belt. What would make that happen? What would make asteroids come out of the asteroid belt? See if you guys can figure that out. What could be something that could make an asteroid just... Because they can't just decide to change orbit. And usually people guess something that's a little bit off for this. Okay, so that's exactly what I wanted to hear. It is technically possible that they could bump into each other, and then, you know, when they ricochet, one of them could end up flying out of the asteroid belt. However, that is really unlikely. That is really unlikely. It is possible, but it's really unlikely. Let me explain why. And somebody did get the correct, or at least the more correct, actual answer to the question in there, and I'll talk about that in a second. But let me explain why it's unlikely that they will bump into each other. Now, I want you to imagine an asteroid belt. Just close your eyes, imagine an asteroid belt. Now, you're probably imagining something like out of Star Wars, right? You're probably imagining, like, is it probably easy to fly in a straight line right through the asteroid belt? Not in a sci-fi movie, right? Not in a sci-fi movie. In a sci-fi movie, you see a ton of big asteroids all over the place, and you have to zoom around them. You just, whoa, 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 hit the brakes. Oh, no. But that's not actually what the asteroid belt looks like, okay? I said that there are millions and millions and millions and millions of asteroids in the asteroid belt. But do you guys know what the asteroid belt is mostly full of? Do you guys know what the asteroid belt is mostly full of? Answer's not asteroids. What is it mostly? Here's a hint. It's the same thing that the entire solar system is mostly. So it's a little bit of a trick question here. What it's mostly made out of is nothing. It's mostly made out of empty space. Okay, so yeah, the actual physical material of our solar system is mostly hydrogen and helium. But if you just look at the entire volume of the solar system, it's almost all empty space. So if you were to look in the asteroid belt, if I took you and put you in the asteroid belt, even though there's millions of asteroids in there, the big ones are so far apart, you might not see any of them. You might not see any of the big ones. They're spaced so far apart that they're really not going to have, we're not going to have big asteroids hitting each other all the time. So what is the real thing that actually gets those big asteroids out of there? Somebody actually already posted it. It's gravitational pulls, okay? But not gravitational pulls of asteroids. They're not going to really have that much gravity to really knock each other around. What is nearby to the asteroid belt that has a decent amount of gravity? What's near to the asteroid belt that could have enough gravity to pull things out of the asteroid belt? See if you guys can get that. Jupiter's one, planets, right? The planets that are next to the asteroid belt can use their gravity to pull asteroids out of the asteroid belt, okay? And if they pull them just right, if they pull those asteroids just right, they could end up orbiting around that planet. And if that were to happen, what would we call that asteroid from then on? If that asteroid started orbiting a planet, what would it now be called instead of an asteroid? If it were orbiting a planet, it would then be called a moon. So some moons are actually trapped asteroids, especially on planets like Jupiter and Mars, and even Saturn. They've all captured some asteroids and turned them into moons. That's actually one of the reasons Jupiter has so many moons, because it's right up there on a big source of new moons. But that usually doesn't happen. What usually happens when the gravity of a planet grabs onto a asteroid, it'll usually kind of end up flinging it in a random direction. And sometimes, rarely, that direction ends up being at Earth. Okay? We're a tiny little target, so usually we don't get hit by these flung asteroids, but sometimes they will get flung at us. Okay? So yeah, in general, you can think of the asteroids in the asteroid belt just orbiting like tiny little planets. And in fact, as we said, some of them are really big, like Ceres. They're big enough to be round. And if they're round and they're orbiting the sun, what does it seem like we should call them? What should we call them? What does it seem like we should call these asteroids that are round and orbit the sun? What does that seem like the description of? Seems like the definition of a planet, right? Seems like a planet would just be a round thing that orbits the sun. So if there are thousands of asteroids that are round and orbiting the sun, how come we don't call those planets? Well, there's a pretty simple reason. Number one, if you were to call anything that was round orbiting the sun a planet, instead of having just 8 planets, if we included all these round asteroids, there would be thousands of them. There would be thousands of planets. So instead, it turns out the definition of a planet contains more things than just being round and orbiting the sun. It turns out that one of the other things that you have to be able to do is you have to be able to use your gravity to clear out your orbit, okay? We've defined a planet so that no 2 planets can share an orbit, especially not 1,000 planets. And if we called all these round asteroids planets, there would be thousands in the same orbit. So in order to be considered a planet, you have to have enough gravity in order to fling everything else out of your orbit. So if Ceres was a little bit bigger, actually it would need to be a lot bigger, it would have enough gravity to fling all the rest of the asteroids out of the asteroid belt, and then we would call Ceres a planet. But because it's not able to do that, and the other thousands that are close to that size are not able to do it either, they're not considered planets, okay? So you have to be able to clear out your orbit. You have to be the unique thing in your orbit, essentially.